Solubility is the amount of solute in solution at a given temperature. In this demonstration, the relationship between solubility and temperature is explored. Potassium iodide and lead-2 nitrate solutions are mixed in an Erlenmeyer flask. What happens? How soluble is lead-2 iodide in water at room temperature? With time, the precipitate settles. A dynamic equilibrium is established between the dissolved solute and the precipitate. The investigation to determine the effect of temperature on solubility begins by decanting and washing the lead-2 iodide precipitate. Deionized water is then added to the pure solid lead-2 iodide. The mixture is heated. Several minutes after the stirring has stopped, the excess solute settles to the bottom of the flask. The temperature is maintained near 100 degrees Celsius. Describe the liquid layer in the flask. The individual mass of 6 empty test tubes is determined. The test tubes are placed in a hot water bath. Using a warmed and rinsed pipette, exactly 20 milliliters of the hot saturated solution are transferred into each of 6 test tubes. What assumption is being made about the amount of dissolved solute in each test tube? One sample of the hot saturated solution is placed in a boiling water bath that remains at 97 degrees Celsius. And 3 are placed in constant temperature water baths at 70 degrees Celsius, 50 degrees Celsius, and 25 degrees Celsius respectively. Another sample is placed in an ice water bath at 0 degrees Celsius. A 6th sample is allowed to slowly change temperature to room temperature. What is observed in the test tubes that cool? The test tubes remain undisturbed for 1 hour. What does this passage of time ensure? Compare the contents of the test tube in the boiling water bath to the cold water bath. Based on your observations, what initial interpretation can be made? To determine the amount of solute that has crystallized out of solution, the test tubes are quickly removed from their respective water baths. Immediately decanted, and the residue is dried. The mass of each test tube and dried solid is weighed. The mass of the test tube and residue, subtract the mass of the empty test tube, equals the mass of the lead-2 iodide residue. The mass of the dried lead-2 iodide is determined for each temperature. From the table, what trend exists between temperature and amount of residue? For lead-2 iodide, what generalization can be made about the effect of temperature on the amount of solute that remains in solution? Now let us revisit the solution that was not placed in a water bath and as a result cooled slowly to room temperature. Do the crystals form differently when the solution is cooled slowly as compared to when it is cooled rapidly? Did the slower cooling process affect solubility? What have you learned about the solubility of lead-2 iodide and temperature?